Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Izanti Aminah binti Fazil and my student ID is 2021610862.
I'm Nurina Darirah binti Ibrahim. My matric number is 2021873568.
Assalamualaikum. My name is Nur Shifa binti Zulkifli and my student ID is 20218696 and 698.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wanu Izatu Ifa binti Manazbe and my student ID is 2021464064.
Hello and Assalamualaikum. My name is Noor Azul Shakira binti Azman and my matric ID is 20212118.
First of all, I will talk about the introduction of our group project, which is about the quantitative analysis of caffeine concentration in pharmaceutical formulation using titration method. Quantitative analysis refers to the systematic and precise determination of the amount or concentration of a specific substance or component in a sample. It involves the use of analytical techniques and methods to measure and quantify the desired analyte. Various methods have been developed to quantitatively determine caffeine in pharmaceutical formulations. One of the methods is the iodometric titration. Iodometric titration is a titration method which also occurs in a redox reaction. More precisely, when iodine appears or disappears when the titration process is complete or reaches the end point. This method uses volumetric chemical analysis. The iodine will later be released in the presence of a reaction with the analyte. This titration process will use sodium thiosulfate. This sodium thiosulfate is also known as a reducing agent to titrate the iodine. From this process, we can find out the concentration of the oxidizing agent in the solution that are being tested.
For my part, I'm going to present about theory of caffeine and titration. Caffeine is a natural stimulant that belongs to the xanthine group of compounds. It is found in various plants including coffee beans, tea leaf, and cacao pods. Caffeine is a stimulant that affects the central nervous system by blocking the action of endorphin, a neurotransmitter that promotes sleep and suppresses arousal. This means that it can help increase alertness and improve concentration. Titration is a process in which a standard reagent of a known concentration for a burette, the titrant, is added to a solution containing the analyte until the reaction between the analyte and the reagent is judged to be complete. During titration, an indicator is often added to the reaction flask to signal when all of the analyte has reacted. The equivalent point is the point at which the amount mole of added standard reagent is equivalent to the amount mole of analyte. The end point is the point in a titration in which indicator changes color.
Okay, next for methodology, the first one is to transfer 15 centimeter cube of standard caffeine solution or the solution that prepared by the extract to a conical flask and add 10 centimeter cube of sulfuric acid. Number 2, add 25 centimeter cube of standardized iodine solution to the mixture and swirl gently. Brown red precipitate will form. Number 3 is to filter the solution. The fourth one is to take down the initial reading of burette. The fifth one is to titrate the filtrate against a standard sodium thiosulfate solution. Okay, so the next step is to add a few drops of starch solution when the titrant became pale brown. Next, slowly run Na2 as 2O3 until titrant become colorless from dark blue. So the next step is to take final reading of a burette, and the last one is to repeat the above steps until 2 or 3 consistent results are obtained.
Assalamualaikum. I'm Nurina Darirah and I will explain the example of results. The table shown here is an example of result from Journal of Tropical Pharmacy and Chemistry. This study uses sample of a pharmaceutical dosage form of tablets containing caffeine and serve as an analgesic drug. And this tablet is very popular in the community and is often used as a medicine for headaches and pain relief. This study was conducted using iodometric back titration method. Iodometric back titration is a simple and accurate method for the determination of caffeine in aqueous solution or water-soluble sample. In acidic solution, caffeine reacts with iodine to form an insoluble brown-red complex. As you can see in the table, the average caffeine content found for each tablet sample has slightly different compared to the amount of caffeine stated in the label. The percentage of each tablet was also obtained, and the lowest percentage found in Paramex drugs of 84.73% and the highest in Panadol drugs was 99.15%. Relative errors are obtained with a range between negative 15.27 and 0.85%. Amount of caffeine can be identified by separate insoluble precipitate occurs from reaction of caffeine and iodine in acidic environment by filtration. The iodine contained in the filtrate is residual iodine after the addition reaction with caffeine. The quantity of iodine that reacts with caffeine can be calculated by subtracting the amount of iodine added with the remaining iodine. From this information and the stoichiometry of the reaction between the reagent and caffeine, the amount of caffeine in the original solution can be determined. And the percentage of purity can be determined by this formula, which is mass of caffeine divided by mass of drugs times 100.
Next, the safety precaution. Firstly, standard iodine solution need to be standardized with sodium thiosulfate in order to get a correct concentration. This is because iodine solution is volatile and it can be easily lost due to evaporation. This may cause an error in the titration. Secondly, when the standardized iodine solution is added to the mixture that consists of standard caffeine solution and sulfuric acid, it needs to be swirled gently to prevent the reduced concentration of caffeine due to the splashing of the solution. And last but not least, before titration, we should remove the filter funnel from the burette to prevent an increase of volume of the solution in the burette. My name is Nushifa. Now I will proceed with the conclusion. In conclusion, iodometric back titration is one of the methods to determine the quantitative analysis of caffeine concentration. A correct amount of the caffeine concentration can be calculated by using this method. Iodometric back titration is a cheap and simple method. It is because this method doesn't require too much apparatus and is easy to conduct. Besides, the amount of caffeine can be calculated by using the formula percentage of purity. And lastly, the reference. That's all for us. Thank you.